That's what I'm here for. I'll do my best to answer them. Now, you've only got to look at this thing to realise it is quite large, made of a lot of steel, so it's going to weigh quite a lot. To let you know the weight involved, if I start off first of all with this area the boat sits in, this big metal tank, its correct name, by the way, is a caisson. But more often than not, people refer to it as a gondola, including the manufacturer. And why it's called a gondola, I have absolutely no idea, because I've been to Venice and gondolas don't look anything like that. But the gondola and the water in it weighs 300 tons. Same with the one up there. Add to that, the two big arms, bit in the middle, everything else that goes round with us. The total weight we end up moving is 1,800 tons. And you'll notice I have not included the weight of boats and people yet. And I haven't included them quite simply because it doesn't matter. You can put as many boats as you want in here, fill it full. You can have that one full as well. Or you can have one full, one totally empty. No matter what combination of boats you put into the wheel, it will always weigh 1,800 tons. And it will always be perfectly balanced side to side. And we don't have to do anything to achieve that. And in case anybody's confused by that bit, I'll better explain. As each boat comes into the gondola, it pushes or displaces its own weight of water back out the way. Archimedes' principle of displacement. That way the weight inside always stays the same. Archimedes. To move the 1,800 tons round, we use hydraulic motors. There are 10 of them. They're driven with a big hydraulic pump, and that's powered by electricity. And the electrical power it takes to move 1,800 tons, quite amazing. I've got lots of technical figures I can quote you, but I'm not going to do that. I'm going to give you a number that's easy to remember. On this trip, to move from the bottom to the top, the amount of electrical power we will draw would be the same as if you took your electric kettle at home and boiled it 8 times. That's all it takes.
What are you doing down there?
Now, did anybody happen to wonder what would happen if there was a power cut right now when I'm talking about electricity? If you didn't, I bet you're starting to think about it now. Anyway, it's not a problem. We're just passing what we call the centre axle. That big grey cylinder goes right through the middle of the wheel. That's made out of 3-inch thick steel, so it's hollow inside. There's nothing in there at all. It is literally just a big empty drum. But if there's a power cut, our maintenance man runs up some stairs, opens a door into that. Just inside the door, there's a big red and yellow lever, which he has to pull very, very hard. Because when he pulls that lever, he releases the biggest box of hamsters you have ever seen in your life. Sorry. Joking apart, just in case anybody is worried, we actually do have a standby power generator. Now, surprisingly enough, the primary function of the wheel is not to provide the goods sales with a trip and a day out. It's lovely to have you all here, but the main reason for the wheel being here was to recreate a link between 2 canals. So once again, boats can move from one canal to the other. 2 canals involved. Behind us, we've got the Forth and Clyde Canal. That's going down to, coming from, on the left-hand side, the Forth, down at Grangemouth, which you can actually see now. If you look over there to the left, you'll see a big tall chimney sticking up. That's Longarnet Power Station, one of the last coal-fired power stations in the UK. I'm not actually interested in that, but just to the right of it, there's a big patch of water. And that is the Firth of Forth there. And that's the point where you make a left